Hey everybody, this is Larry. This is day 10 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today's poem is add binary. I feel like I've done similar poem before on this channel, maybe even multiple times. There are a couple ways you can do it. Let's do it kind of in spirit. And that may mean a couple of things, but at least like what we shouldn't do, or at least well, let me restart a little bit. Let me say that when you're doing these problems at home, try to work on what you think you want to improve on, right? Like if you already know this and you think it's just typing, then that's fine. You don't, just do whatever, like convert it to the many languages have libraries for these, so you could just change it and then add them in int and then change it back to binary or something like that. So that's going to be a one-liner and you can do it if you want. But of course, just try to challenge yourself to kind of make sure, think about the edge cases and stuff like that, and then just, play around with it. I think that's the idea that I would recommend, right? Like at the end of the day, you're doing it for yourself. Hopefully you're not doing it for me. I don't know why you would, but you're doing it for yourself and just practice and sometimes the hard part of a problem is the annoying stuff, and practicing that and kind of reading code and going into and kind of thinking about planning it ahead of time so that you can write the short code. That's going to help you in other problems in the future if you want to do it, if you feel like you need to practice, right? And not everyone needs it per se, but that's what I would say for problems like this, where it's it's but I would say this is a good opportunity in general to do two things. One is to kind of play around with the idea of a big int, this time in binary, but still a long int because the length could be very long. And then the second thing is that, as I was going to say, especially in Python, big int isn't really a big thing that people think about as much anymore. But at least back in my day, for whatever reason, it used to be a more common thing that there were problems that kind of forces you to like the library functions didn't do, or just for a long time there was no big int function, or there's no big int support in the competitive languages. Like I don't think there was one in C#, but it's not in the standard library. C++ has boost, but people didn't get to use boost in the contest. So I think for me, to be honest, I usually cheat back in the day, just to kind of give a little bit of a story, I suppose. I usually cheat in the day by using Java, because Java, and this was I think 1.3 or 1.4, or just 3 or 4, I guess actually. But yeah, back then Java just allowed you to. Java did have a big int library, so I took advantage of that from time to time. I would say people are very smarter about it these days, and or people are just like, in terms of competitive programming anyway, the problem setters are more deliberate and they're not trying to fool you on that. So that's where you see all these mod problems, right? They do mod problems because so that you don't have to know that much, or you don't have to have a big int implementation ready, because back in the day, if you had a big or not if, because I think all the top people just had a library that did it for them. But as a result, everyone had to do it. And if you were a little bit new, you're like, oh, I haven't done this. And then it's like, well, too bad. I guess you're not solving this problem, right? So that's kind of some of the backstory, I would say, about big int, and why. And this is also why if you see a lot of these random problems with like, oh, why am I doing modular math? It's so that they can ask problems that maybe related to combinatorics, something like that, but these problems that are very hard to do without big int, because otherwise you're just doing like n is equal to 30 and or something, or I don't know, whatever, right? And that is like, you could do it in like n to the third, even though they want a O of n algorithm or something like that, right? So something that forces a big answer without requiring big int or big integer, just to be clear. Anyway, okay, that's probably enough of a storytelling. I don't know. I mean, this is a easy problem, so I hope you enjoy the story anyway, because I think there's so many. I mean, there are many ways to do this, and it doesn't really matter. The way that I would also, or the way that I would recommend as well, is just if you do struggle with this one, I mean, adding is a little bit easier, I think, but obviously subtraction is a little bit trickier. Multiplication is kind of also okay, but annoying. And then division is probably the tricky one. And yeah, just the thing that I would say is, I always off the camera, I always actually have pen and paper ready. Usually doesn't need it for Leetcode except for relatively rare occasions. Some stuff about visualization, but for Code Force, for example, I would always have pen and paper because that's just, or pencil and paper because I waste a lot. Because my head isn't big enough, I suppose. So yeah, so definitely don't be ashamed of it. Like work it out and rework those principles because everyone knows how to do these. Beyond third grade or whatever it is. I don't know when they teach these things anymore, but it's just about changing that algorithm that you already know and maybe love into code, right? So that's the thing I would say, and that's pretty much all I have for this one, except for some doing the problem. So let's get at it. There are a couple of ways you can do this. You can do this by writing a preliminary, like a big int class if you like. And you could just structure it as much as you like, class begin, and of course Python already has support for stuff like this, so big binary int maybe, something like that, and then fill this out, right? So you can fill this out in this way. You initialize the class and then add and so forth. So I was actually debating whether doing this mostly because I'm a little bit on the lazier side today, but let's do it. So let's do initialization of this requires a string, so let's just say s, and then here maybe we have let's just say we could convert it to yeah, let's just say we have I don't know, and we can do this as silly as possible for this case, but of course in real big int things, well, one is that there are also libraries out there, so use it as much as you can. Two is that a lot of them are open source, so read the code as much as you can, but if you want to do it by yourself from first principles, we're doing it binary here, and sometimes you do it on base 10, but of course the more space efficient way is to have each int mapped to each other, which means either 32-bit or 64-bit thing to kind of do the math. These are some to compress the space. These are just like in base 2 to the 31st or whatever, right? Or 30th maybe, depending on what you're doing. But yeah. So these are just things I would say. So yes, so I'm doing this like as maybe silly as possible, but yeah. The way that I want to think about this is actually, do I want to do it this way? Maybe not. I was gonna just append it and then have basically the least significant digit at the back. Is that reasonable? I mean, I guess it doesn't really matter, but then you have to add new digits in the front, so it's a little bit awkward. So let's actually do this backwards. And then we can do, and that's pretty much it. And then now we just have to do the add function, and then you have b. Oops. Yeah, I mean, this is pretty okay. So I mean, you could add some helper things as well. Like you could add like the length or something like that. I don't know. I'm a little bit lazy today, so definitely feel like you could add as much as you want, but yeah, maybe that's fine. I don't know. And of course, you would maybe like do an assertion to make sure that it is the same type and stuff like that. But for now, for this particular one, there are a lot of good readability principles that you can do. And I'm ashamed to admit that I'm a little bit tired and lazy today, but feel free to do it however you like. So yeah. And like I said, practice it and do whatever. This is a start, a template, but you can definitely make this cleaner. I don't want to say that my code is the cleanest, especially for this one, because I am a little bit lazy today. So that's my disclaimer. That's all. But yeah, so let's just say self n, maybe. I don't know. That's a good thing, but length of self.bits. And then, yeah. And then now we look at it each bit at a time. So yeah, for x in b, maybe? No, I mean, I guess we can do it, but we'll also enumerate it, right? So then now, I guess we don't need this really. Maybe, I don't know, we'll see. And then now self.bits of I, we add it to x, right? And that should be good, except for if I is bigger than whatever. So yeah, if I is greater than or equal. I don't know why this would happen, but or at least the greater than part it would be at most equal to. Right, and then now we can do the carries together. I mean, you could do it in a number of ways, I guess. You could do it here. Okay, let's just do it here instead of collecting all the carries together. If so, that bits of I is greater than 2, I guess. Yeah, okay, because this is base 2 essentially. I guess I could just do it this way. And then sub that bit of I is my equal to 2, right? Nope. Yeah, and then of course at the very end you want to return back to a string, so let's have a string function. And this one is maybe I guess there will be no leading zeros in this case, but of course in a real big int class you would have, you know, like you would have to take care of a lot of extra cases, but except for maybe 0 itself. Can I add up to a leading 0? Well, this is where if you're building a library where test cases matter, so you'll just put stuff in as you need it. So in this case, one thing that I want to think about is like just adding the 0. I think all the other stuff I'm pretty okay about. Also, I lied because I think this should be this. And then we said carry is equal to, it should be equal to this. Okay, maybe that's right. I mean, but this is what I wanted to say was this is what we have. This is why we have all these test cases, is so that we can, you know, verify these things, so that, you know, you're not burned by getting everything right the first time. Though of course that feels great if you do, but that's what test cases are for, so that as you add and change code, everything is behaving as you expect. And of course, if you believe in test-driven development, TDD, you would actually write the test first and then verify that it is incorrect first, because if your test cases already returns the quote-unquote expectation of the test correctly, then that means that you're probably doing something really, or like your test is maybe useless, because whatever code you're writing doesn't change anything, right? So yeah, or shouldn't change anything. Maybe that's a good test. I don't know. Depending on the scenario. Maybe I take that back a little bit. Anyway, but yeah. So then now we just tick up, and of course I'm a little bit lazy in my writing, so yeah. So we can just do this, I think. What I mean by that a little bit lazy is that I definitely use this a bit to do the reversing, which of course takes constant space. Oh, sorry, linear space. But yeah, what happened here? Oh, I forgot to actually write this code. So, but yeah, so it does take linear space, which is obviously not ideal. You could do it without, but whatever. Or a linear extra space, because in this case, that's the size of the string you're returning anyway. But this one is unnecessary, for example. You could just do it for the backwards, but I'm a little bit lazy. Yeah, so that means that we just have to return big binary int of a, add big binary int, and you could also overload, but actually I don't. Yeah, I don't have that yet. So yeah, something like that, right? Not editable. Oh, whoops, speed.bits. And of course, this should be private. That's another story. Also, I return none for all of these. Wow, yikes. Why should that return none? Tell me why. Where's my printing? I know why. Because okay, fine. There is some like weirdness with Python with return auto string conversion and stuff. I think I had to do I had to call this like this or something like that, but representation maybe. I could be wrong about that actually, but it's a little bit awkward. So I don't know. I mean, well, also it's still wrong. Tell me why. I mean, but okay. But we also just I'm not gonna lie. So in the real world, I would look it up. Oh, maybe my syntax is just really wrong. I'm not gonna lie. I'm really shaky on the syntax now. Now that I think about it, because I haven't done this in a while. But I mean, it's not even calling these things, is it? It's not. It didn't call this function, so. Okay, so now this is printing none for these, which is okay. So this is returning none for some reason, maybe. Let's see. Today we get to learn some stuff. That is really awkward, isn't it? Okay, I mean we can keep on debugging, but did I do something weird? I mean, so this looks well. This one's wrong, but it looks good. I forgot. See, this is where you have to come up with good test cases. But actually, I forgot this way of carrying it. So then now, so because that would actually give us the right answer. But I don't know why this is returning something funky. Maybe I do know. I don't know. Print stop that. Am I just doing this weird? Yeah, I mean this would be the answer that we want, but for some reason we're maybe I'm just like really bad with the syntax. I have to look it up. It's been a while since I do. Well, I'm not gonna lie. This is the risk of doing these live. Okay. Why? Oh, I see. I am just being dumb because this actually doesn't chain because it doesn't return self. So this actually returns a none object, and then we just do a string to it. So of course it's going to return none. Oh wow, I am just a little bit sloppy because I'm used to writing chainable stuff, but then I was like, oh, this doesn't make sense. So yeah, okay. Now we get the wrong answer, which is a little bit sadder, but let's see. Where did we go wrong? So one. How did that happen? Man, I am very sloppy today. It seems like. Though I really, it works for this big cases. So, oh, I see. I see. I was a little bit sloppy, for sure. And this is just one because I assumed that B. So the edge case that I worried about was that B is bigger than A, but this can actually, if A is bigger than B, then we have bits left over. So yeah, so we have to kind of contain you for I. Well, I is. This is a little yucky. While I is less than length of self dot bits, and then we have to do this thing of propagating the bits, the carry. I mean, yeah. Huh. Wow, I am just a little bit sloppy right now, to be honest. Why does that? What happened here? What happened here? Because basically bits of, but I should be. Yeah, we need I to kind of. So basically, I could give a bit more illustrative example, which is this. It basically only it terminates early, but I thought that this would let me not terminate early. But it's just not adding one at all for some reason. I mean, that made it worse, but yikes. I was pretty confident about this, but yeah, but I don't know how that actually messed it up even more. But yeah, basically there's a carry here, and then it just add the carry to the front, which is actually not what we want, or at least not directly. But basically I should be, that's weird. Shouldn't I, like, why is this not working? And I am way not way sad today. I mean, my code is sad. I'm not sad. But, yeah, 0. So it's done. Oh, I see. Because I is that is one thing that I always forget about from between Python and other loops, is that in C++ loops, because or just like C like loops, because this is not enumerate, it doesn't go through, I doesn't go through all the elements. I, in this case, it is actually the last item on the list, instead of like if you have a for I less than n loop, at the end of this loop I is equal to n, but in this case it's actually I is the last element, right? So it'll be n minus 1 in that case, which is why we're having some weirdness. Hopefully that's it. But yeah, I always forget that one. That's a nice gotcha, actually. And that's why we have these testing, right? And I did do a little bit of a poor job, because in this case, obviously adding is commutative, right? Is it? Yeah, commutative, right? A plus B is equal to B plus A. But my code might not treat it that way. So I have this, but I don't have the inverse of it. And I mean, we kind of made it later on, but that is something that we should have had as well. Okay, let's give it a submit. Maybe it's wrong, but maybe that's fine. I'm a little bit lazy on the testing today. So yeah, 650 day, consistency is key. See you tomorrow, as they say. That's all I have for this one. I don't really have much to say. I mean, I think was I lazy last time? I don't know. Let's see. No, I actually did it. Okay. In a not big in kind of way, but yeah. But yeah, that's pretty much all I have. This is linear time, linear space. Linear is the size of the input. We don't really do anything funky. We just do well, maybe a little bit funky, but we do a bit of for loops, and that's it. So yeah, that's all I have for today. Hope story time was okay. Hope y'all doing great. It's Monday or Sunday, depending on where you are. Have a great weekend. Well, I hope you had a great weekend, but have a great week. I'll see you soon. Stay good, stay healthy, to good mental health. See you later. Bye bye.